everyone. Welcome to our session here at KCD Tel Aviv. We're super excited to be here today, and we're going to be talking about how to avoid the dev plateau with CRDs. First, let me introduce my brilliant colleague and the most amazing solution architect we have at Komodor.
I'm very excited to be here, and let me introduce you to Rona, one of our most awesome developers in Komodor. So in Komodor, we developed the Kubernetes operation troubleshooting platform, but we are not here today to talk about Komodor, so if you want, you can check our website or our booth. And without further ado, let's get started.
Yeah, and we didn't match the outfits today, so so let's start. So I want to take you deep into the ocean. I want you to bear with me for a second and think about the ocean as Kubernetes. It is vast, it is deep, it is powerful, it is infinite. But you'll think that something is missing here, right? There is almost no fish or no coral here. And at the end, we would like to create a healthy ecosystem in it. So what can we do? We can put a man-made object into the ocean as a base for ocean life like coral and fish. And once we do that and we put this man-made object into the ocean, it will attract ocean life to it. And we will get a very thriving ecosystem. So why am I even talking about it? If the ocean is Kubernetes, then the man-made object is the platform or CRD. And this is the beautiful, thriving ecosystem that can be created out of CRDs. So to sum it all up, CRDs can be the base for you to extend your Kubernetes cluster with new capabilities based on your needs. Now, before we dive into CRDs and their usage in Kubernetes, let's talk a bit about how Kubernetes adoption looked like when Kubernetes started. So, the early adopters were not only small startup companies that were trying to save money, but also large companies with great budget and talent like Google. But in between these small startups and Google reside most of the companies, right? And most of them had to face big challenges in order to adopt Kubernetes. So Kubernetes took an approach to add more core functionalities for wider adoption for these companies. So they had things like deployment, stateful set, and other application capabilities that allowed organizations to utilize and adopt Kubernetes. And therefore, Kubernetes became the dominant platform, but there's still a lack of enterprise concerns. So to support the demanding challenges for adoption, Kubernetes is now adding more and more enterprise capabilities. Things like security and data are now top concerns, and they've been changing a lot in recent versions. And if you look at recent versions, you'll see that it's more on the enterprise side than on the core side. And that's fine, actually, because like any other technology, it went into the phase of what will take us to the next step.
So what we do, we basically break down the top feature that Kubernetes offered from like earlier version to the latest version. And we see that at glance and at first, they do a lot of core capabilities, make sure that every organization can adopt Kubernetes. And when we take a look about later versions, we can see that more enterprise functionality added in to support all of kind of users and to gain user adoption for wider organization. Let's break it down a little bit to two specific versions. So if you take down, for example, per version 1.9 versus Kubernetes version 1.25, which is one of the latest versions. We can see that in Kubernetes 1.9, one of the things that were added, or most of them, is what you're familiar with most of your clusters. Like you cannot imagine your clusters without deployment, stateful set, daemon set, and they also added a lot of capabilities around non-Kubernetes native workloads like GPUs, Windows support, and that's what allows to gain a lot of user adoption from early adopters at early stage. But when we break it down to 125, which is released last year, you can see that applications and non-native workloads are not in the top mind of Kubernetes maintainers, and security and storage take the most of the features and the capabilities, which is not bad, right? Because we can adapt Kubernetes to a wider group of users. But in fact, that Kubernetes challenges are just growing, and they are always growing. So in order to, for example, adopt Kubernetes, it's not just to run my application, right? I have technical challenges, I have business challenges that I must have, and they are not part of Kubernetes. Kubernetes is not built to do the monitoring, the auto-scaling, the cost reduction, the optimization that you're looking for. It's just not supposed to do that. So when Kubernetes decided on what is the core functionalities of it, it actually decided what is not core functionality. And you, as DevOps, SREs, developers, you need to find solution for all of these. They will not come out of the box. And those challenges, this is what block users and end users from adopting Kubernetes. So let's take one example. Let's say I have my gaming app, and in my gaming app, I have pods that can support only 10 users at a time, like 10 concurrent users going into one pod, and this pod can do all the graphic, all the analytics, everything required for that users to grow. But I need my gaming application. If I want it to be successful, it obviously has to have the ability to auto-scale, right? But HPA is quite not there. It's built on basic metrics like memory and CPUs, and I want like my services to be auto-scale based on the number of concurrent users on the website. And because HPA does not support that, I need to find a solution. I have to find a solution because without it, I cannot auto-scale my gaming app. So CRDs can be the answer for it. Rona, can you walk us through a little bit?
Sure. So let's talk CRDs. Thanks to Kubernetes, we can create our own custom resources such that everyone can create their own custom resource and controller to extend the Kubernetes API with new resources. So CRDs, CRs, and controllers really provide a powerful way to extend Kubernetes and manage your application resources in a more flexible and customized way. So as a user, I can either use some third-party tool that utilize CRDs like Argo Rollouts, or I can create my own custom controller like Guy's Gaming Autoscaler. So if I were to install the Gaming Autoscaler on my cluster, I could just run kubectl get gaming autoscaler, and the same Kubernetes API will retrieve all the information it has on the gaming autoscaler. And that will be the same as if I were to run kubectl get pods, for example. Now, let's talk a bit about how it works. The Kubernetes operator uses custom resources that define the desired state and configuration of a specific application using custom resource definition. When I create an instance of a custom resource, Kubernetes stores it in etcd, and then this resource can be managed and accessed using some API endpoint, just like any other Kubernetes resource. So if you think about it, CRDs together with Kubernetes operators really give you unlimited possibilities, and you can basically do whatever you want. Okay, so that's all nice in theory, but let's look on how you can create your own custom resource. So if I want to create my own custom resource, I need to follow 3 steps. First, I need to define my custom resource definition that defines the object type and its schema. And when I apply it, Kubernetes will just create a new API endpoint, and that will allow me to interact with objects of that type. Okay, but CRDs alone are not enough. They won't do much. So you need to follow step 2 and create a controller. So the controller is just an application that is deployed to the cluster as a pod. And it basically listens to the Kubernetes API and watches for changes of the state of some object, and then performs actions based on those changes. And Third, you need to create a custom resource, which is just an instance of an object that is defined by the CRD that we created in step 1. So if you follow these 3 steps, you will create a hopefully working custom resource of your own. Okay, so now that we know how to create our own custom resource, let's look at some more elaborated example of how can we use third-party tools that utilize CRDs in order to solve some common day-to-day issues that I'm sure most of you have came across. So Guy and I wrote a very simple and cool application, just one deployment containing 2 pods, which are quite similar to Guy and I today, and now we want to autoscale our deployment based on the number of messages in the Kafka topic. So what is the problem here? The problem is that we cannot use the built-in HPA for that, and we need to find another solution. And that solution is K8s. And K8s is a Kubernetes-based event-driven autoscaler. And once you install K8s, it actually creates 4 custom resources for you. And those resources enable you to map an event source, in this case Kafka, to some resource for scaling. So if you look at it, K8s actually provides everything that you need, the CRs, the CRDs, the controller, in order to perform some advanced autoscaling.
And after a while, we run, and we had to add some security, right? Because if this successful application is running fine, but we don't have security, some CISO will come and tell us, okay, you need to add some certificates. And obviously, no one likes to manage certificates. How many of you don't like to manage certificates? Oh, wow. Almost all of you. And certificates are really, really hard to manage, right? We need to create them. We need to renew them. They are sometimes want to expire. And the fact that they are not part of Kubernetes native resources make it hard time for us to integrate and orchestrate our certificates. And what happens is that there is a project called Cert Manager. I guess some of you heard of it. It allows us to extend the Kubernetes API, add certificates as something like first citizen in our Kubernetes clusters. And now we can just define, I want our certificates and I want to mount this to this pod, and everything should be automated for me. And it allows us, instead of writing our own script or our own code, actually to integrate, add certificates, and make our life much, much easier. So it's not the last challenge that we faced with. What else that we got?
Okay, so next, let's talk monitoring. So Guy and I configured some Grafana monitors manually, but that's really bad practice, right? You don't want to do anything manually ever. So we want to pack our application together with the monitor's configuration, and we want it to also be in Git. So we will have history, version management, and more of a GitOps implementation, if you will. So what we're going to do, we're going to use Alert Manager CRDs. And the Alert Manager CRDs declaratively define the desired Alert Manager setup for you to run on your cluster. So, Guy, what about our CD process? What are you going to do about it?
Yeah, so when we started, we wrote our own script that does a lot of kubectl commands, do the apply, and then verify all the pods are running. But it's really, really bad, right? We want to use some continuous deployment. And Argo is a really cool project, and is one of the most popular projects in the CNCF, allow us to automate the continuous deployment process. And I know the guys from AT&T talked a little bit about it before. And it's really interesting that instead of the script that we need to manage, that we need to maintain, we can now just create an application, reference to the right repo that you want to have, and we have a full continuous deployment automated for us with zero effort.
Great, that's very cool. So now our next use case is that we want to enforce our configuration policy. But we definitely don't want to do it by ourselves, and we don't want to write some crazy program to do it. So we're going to use Kyverno, which is a policy engine for Kubernetes. And Kyverno also uses CRDs for policy reports, policy definitions, and other internal types. So also in this case, again, we were able to solve some issue using CRDs. Guy, what's next?
And some of you may heard about OpenTelemetry. It allows you to bring a lot of telemetry and APM and metrics to your Kubernetes cluster. And that's really nice. We want to use it. And it's not only that, we want to configure it with infrastructure as code instances. And we want to make sure that we know exactly what we configured. It's streamlined with our CI/CD, and we can also integrate that with ArgoCD to make everything streamlined in terms of configuration. So we deploy OpenTelemetry with the CRDs in it to configure it.
Cool. Okay, so let's talk a bit about Grafana. So we installed Grafana using Helm charts, which is very common practice, right? But now we want to move into an operator that will help us with the day-to operations of Grafana. And luckily, CRDs does not only manage specific things, it also manages databases and any other third-party tool. And in this case, we're going to use CRDs again to manage our own Grafana.
So after our application became a little bit successful, we do want to have some advanced rollouts. In Kubernetes, we have basic rollouts like recreate and rolling upgrade, which is the popular one. But we do need something else. We do need blue-green or maybe a canary rollout. And for that, the Kubernetes basic or stock rollout is just not enough. So we went through with Argo rollouts, third-party tools that will give us blue-green and also canary out of the box. And later, we are going to show you exactly how it looks in real life and how you can turn your deployments from basic and rolling upgrade into Argo rollouts.
Okay, so now we've talked about monitoring, CD, auto-scaling, rollouts, and we've come to our last use case, which is we're going to go full infrastructure as code. So we want to move our infrastructure components in the cloud provider so we can pack our application together with the infrastructure that it needs in order to run. And we want to do it in a Kubernetes native way. So we're going to use Crossplane. Now, CRDs are actually key component of Crossplane's architecture because they allow us to create custom resources that represent infrastructure resources like databases, load balancers, VMs, and so on. And they all can be managed and provisioned using Crossplane. And also, in order to use Crossplane, you need to define the infrastructure that you want using CRDs. So Crossplane is maybe the most clear example we have of a tool that utilizes CRDs. And I think it's really nice and awesome.
And at some point, when we are talking with bigger customers and larger customers, they do want to have more. They want multi-cluster, have service mesh in place. They want to have in-cluster east-west traffic using from cluster to the other, using maybe Cilium or some other routing project. And all of those will not be capable without CRDs. They allow us to build this ecosystem that you see in front of you only because Kubernetes allow us to put extension. Kubernetes understand that the core is not enough, and it allows to any third party and on your own to write the code and extend it. And if you're taking a look about this map, we started with one deployment in 2 pods. We found ourselves with the complete CNCF landscape over the board. And it's really like the ocean analogy that we talked about, that we start with something, we put the platform of the main object, and now we have a full ecosystem in it.
Cool.
So we want to show you a little bit of demo of how it looks like and how you can benefit from CRDs on your own. Cool. So what we are going to show you today is basically we have a deployment. And in our deployment, we do a rolling upgrade in order to get more benefits and value out of it. Sorry, let me make it a little bit bigger. Okay, cool. So the rolling upgrade is not enough, and we do want to have a blue-green rollout. Why is that important? Because of two things. One, we want to have the preview version in order to see it and use it before we are rolling out to the active version. The second thing is that we do want to have a very fast switch. We want to move from the old pods to the new pods in a split of a second, and we do want to have the ability to revert it very, very fast. So what we are going to show you today is a deployment, and then we are going to show you how you can get the blue-green from Argo rollouts without doing basically almost anything.
Yeah, so we have a cluster. We just previously installed Argo rollouts on it. As you can see in 1 minute.
Hi.
Yeah. And let's look at the CRD. Okay, so this is the CRD that was introduced into the cluster by Argo rollouts. And now let's take a look at the deployment we're about to do. Okay, so that's really a very simple deployment, just 10 replicas. The strategy here is very basic. And the only thing that we added is the field of initial delay seconds of 20 seconds, just to show you how it will look like in real time.
So what we're going to show you is that the pods are starting up. And what we're going to get is just a simple deployment, as you know, with 10 replicas. All of them are going to be ready. And let's wait for 20, 30 seconds for it to be ready. And from that point, we do want to do a rollout. Why rollout is important? Because anytime we need a deploy, it's not just to recreate. We want to have a rolling upgrade in place. But just to remember, we do want the fast switch. We do want to have the ability to revert it fast. And we do want to have the preview version of it. So after all of them are ready, we are going to deploy the new one.
Let's look at it first. Yeah, so this is the new deployment. It's the same. We've just changed the image version from 122 to 123. Let's look at the diff. Here you can see that's the only change we did. Let's apply it.
And basically what we can see is that, I guess that all of you know it, but the new pods are going to start, they're going to be ready, but we lose our, first of all, the ability to do a fast switch. Why? Because when the new pods are going to be ready, traffic is going to flow into them. So it means that we don't have a switch. The second thing is that we don't have the preview, because we cannot use them before they're starting to get traffic. And third of all, we cannot do a fast revert, because if we have amount of capacity of users, 3 or 4 pods, which are going to be the last step, is not enough to support all the traffic that we have. So for that, we do want to use Argo rollouts or code it on your own, but I guess no one would like to code it on your own. Yeah. So let's just delete the deployment.
Okay, let's look at the rollout. As you can see at the top 2 lines, the only thing different is the API version and the kind. And this is really the strength of CRDs, because the rollout kind is not default. Yeah, it does not exist by default in Kubernetes, and it's not a core feature. So we were able to use this kind because we installed Argo rollouts. So the deployment is basically the same. We just added those 6 lines of the strategy. This is what you need in order to do the rollout. So we define the strategy as blue-green. Let's see how it looks.
So one of the cool things in Argo rollout is that we don't only get the ability to do the rollout, we also get this CLI plugin that allows us to see, first of all, the first revision that we just applied with the pods. We can see the info of it, that it's stable and preview. When all the pods are going to be ready, it's going to turn automatically to active. This preview version allows us to go to the service using the service preview endpoint. And now when all the pods are healthy, the version is stable and active. But as I said before, we do want to confirm that we can do the blue-green rollout very efficiently.
Let's take a look at the second rollout. The same as the deployment before, we just changed the image version from 122 to 123, and everything else is the same. Let's apply it.
So what we are going to see using the command is we have on the bottom the previous replica set with the 10 pods, which are ready, stable, and active. And the new version came on the top, and all the pods came at once. So we have 10 pods at the top as well. It's a preview version, and when all the pods are going to be ready, we can access it through the service, basically. And what we did is we added the ability to test it for 20 seconds. It means that we have 20 seconds to test the preview version, and Argo rollouts will automatically turn the active revision from the first revision to the second one, which is great. It means that we did a switch, a very fast switch, and all the traffic is served into the new pods, and then it happens. So this is how we achieve, first of all, the ability to test the preview and also to do a very fast switch. And now if we want to revert, we do have 30 seconds to do it. We can extend it with more, but it allows us to do a fast rollback into the previous version without losing the pods, without impacting the traffic of our users. And this is how we're able to get blue-green rollout without, first of all, develop it in our own, or do a lot of problems and hard stuff in order to get it. Just a second. Thank you very much. But we have one more minute. We want to talk about what's next. So what's next is always important, right? External tools, as we saw, they are going to be the main catalyst of Kubernetes as the main platform to use. Second of all, we see that in large enterprises, they do use CRDs for in-house solutions. I will not recommend that to do if you don't have a very specific use case, but it's something that we see thriving and growing step by step. And as Kelsey said, and no one can say that Kelly is wrong, Kubernetes is a platform for building platforms, and that's really what CRD about. The ability to take Kubernetes, not use only the core, but extend it and make it a real platform with a lot of third-party solutions. Thank you, Rona, and thank you everyone for being with us.